Somewhere in a museum drawer in southern China, there is a lower jaw that will not sit in an open hand. The molars in it are wider than your thumb is long, worn flat, with enamel thick enough to crack what was never meant to be eaten. Everything anyone has said about the animal that carried it, how tall it stood, how it moved, why it disappeared, has been reasoned outward from teeth like these. It is the largest ape that ever lived, and it is almost entirely a deduction. The first one was bought over a counter. In the middle of the 1930s, a Dutch paleontologist named von Koenigswald was working through the apothecary shops of Hong Kong, turning over trays of what the trade called dragon teeth. Fossil teeth of no stated origin, ground into powder and sold as medicine. Chinese pharmacies had been quietly collecting the fossil record of an entire region for centuries and selling it by weight. He was buying it back one tooth at a time, and in one of those trays was a molar that should not have existed. Nothing living has a tooth like that. It was a lower third molar, an ape's tooth in every detail of its cusps and grooves, and it was half again the size of the same tooth in a large male gorilla. A tooth is not a scaled ornament, it is a working surface sized to the food it processes and the jaw that drives it. So the tooth implied a jaw, and the jaw implied a skull, and the skull implied a head carried by something with no living equivalent. He named it for its size and for a colleague, and then went looking for the rest of it. 90 years later, the rest of it has still not turned up. The published record for this species amounts to 4 lower jaws and almost 2,000 loose teeth, and no postcranial evidence whatsoever. No arm, no leg, no hand, no foot, no pelvis, no vertebra, not one bone from below the head. Every one of those teeth came out of cave sediment in southern China and northern Vietnam, where limestone chemistry destroys everything except the hardest tissue an animal makes. The record is not thin by accident, it is thin because enamel is the only thing that survived. Look up an image of this animal and you will find a confident one. A huge dark ape, upright, shoulders squared, forest behind it, often with a human figure beside it for scale. Every element of that picture except the teeth is an inference from a living animal that is not this one. The posture is borrowed, the proportions are borrowed, the hands are borrowed, the face is borrowed. None of it is wrong exactly, and none of it is evidence either. What the illustration is really showing you is an argument about which living ape to copy. Working outward from a tooth is not guesswork, but it rests on one assumption that has to be stated. You measure the same tooth in many living apes, you measure their body mass, and you fit the relationship between the two. Then you drop the fossil into that relationship and read off an answer. It is a legitimate method, and it is used everywhere in paleontology. What it requires is that the extinct animal was built roughly like the living ones you calibrated against, and this one is far outside the size range of anything you measured. Do it carefully, and you get a body mass somewhere between 200 and 300 kilograms. That is a real published estimate from people who have handled the material, and it is roughly the mass of 2 large male gorillas. Notice what it is not. It is not a height. A height needs limb proportions, and limb proportions need limbs, and there are no limbs. The tall figure you have read somewhere is that mass estimate multiplied by the shape of a gorilla, a second assumption stacked on the first, which is how a scaling exercise turns into a portrait. So consider what the standing pose in every illustration is actually resting on. To know that an animal stood upright, you need a pelvis, or a femur, or a lower spine, or a foot. This species has never yielded a single one of them. The upright ape you have pictured is not a contested reconstruction or a minority view among specialists. It is a convention, inherited from museum displays and film posters, applied to an animal whose posture is genuinely unknown. On the evidence available, it could have moved like nothing anyone has drawn. For decades the leading idea was that this thing was one of us. The teeth are flat and heavily worn, the canines are small relative to the molars, the jaw is deep, and that combination reads at a glance like the chewing apparatus of an early human relative rather than an ape. Serious scientists argued for years that this was a giant hominid on the human line, and one strand of the argument survived into popular culture long after the specialists had abandoned it. The problem was that the whole case was built on the shape of teeth. The thing that settled it was not a new fossil. Ancient DNA is the usual arbiter, but DNA is fragile and warm, wet climates destroy it quickly, which is why the subtropics have been a blank on the genetic map. Proteins are tougher. Enamel is built of proteins laid down in a crystalline matrix, and fragments of those sequences can survive in conditions where genetic material has been gone for 1 million years. A team took one molar, nearly 2 million years old, and read the protein sequences still locked inside its enamel. What came back put the animal on a branch that is not ours. The enamel proteins place it as the closest known relative of orangutans, a sister lineage, sharing an ancestor with them somewhere around 10 to 12 million years ago, in the great radiation of apes that also produced everything else alive today with that body plan. The dating carries a wide margin, and the authors say so. The placement does not. This was never a human ancestor, or a cousin of ours in any useful sense. It was an orangutan's enormous relative. A tooth records what it was used on, in 2 independent ways. The surface carries microscopic scratches and pits from the last meals of an animal's life, and the pattern of those marks separates a leaf eater from a fruit eater from something that chewed grit. Deeper down, the carbon locked into the enamel, while it formed records which kinds of plants stood at the base of the food chain. Neither method asks you to guess. Both were run on these teeth, and both gave the same answer. Its diet was plants that grow under a closed canopy, a broad vegetarian menu of fruit and leaves and stems, the food of a forest generalist, matching the signature of the orangutans it is related to. And it was not a bamboo specialist. That idea has followed this animal around for decades, borrowed from the other famous flat-toothed giant of the same forests, and the isotope work does not support it. The animal was not fussy about what it ate. It was absolutely fussy about where it ate, and that turns out to be the dangerous kind. Picture the country it moved through. Southern China in the early Pleistocene was tower cast, limestone hills weathered into steep isolated pinnacles, each one carrying its own forest, riddled with caves at the base where rainwater had eaten the rock away, rivers threaded between them, through dense subtropical woodland. It was a mosaic, forest running into open patches and back again, and for something like 2 million years, it was very good country indeed for a large animal that ate leaves and fruit and had no serious enemies. It was not alone in that landscape. In a cave in northern Vietnam, teeth from this animal, and teeth from Homo erectus, came out of the same dated deposit, which places an upright tool-making human relative in the same forests at the same time. That is the whole of the connection. There is no kill site, no cut mark, no butchered bone, nothing that puts the two species in contact at all, only the fact that they were there together for a very long time, and that one of them was still there afterwards. If films about the vanished world are your kind of thing, the Earth before is where they live. The date of its disappearance was, until recently, a shrug. A team went at the problem properly. 22 caves across southern China, more than 150 radiometric dates produced by 6 independent techniques, cross-checked against each other, plus pollen from the cave sediments to reconstruct what was growing outside. That work puts the extinction in a window between roughly 295,000 and 215,000 years ago. It is a range rather than a date, and a range honestly arrived at is worth more than a date invented. What the pollen shows in that window is not a catastrophe. There is no impact, no eruption, no ice sheet. The climate simply became more seasonal. Wetter wets, drier dries, a stronger swing through the year, and the forest responded by breaking up. Closed canopy gave way to open woodland and patches of grass. For most of the animals in that landscape, it was an inconvenience. For one of them, it was the removal of the only environment in which its body made sense. Here is the part that ought to be uncomfortable. Its close relative, an orangutan of the same forests, went through exactly the same centuries and came out the other side, because it changed what it ate and how it moved and how it used the year. The teeth of the giant tell a different story, chewing wear that shifts toward tougher fallback food, chemical banding inside the enamel that goes ragged the way a stressed animal's does, and fewer teeth in each successive layer. It did not adapt, it endured, and then it stopped. And then it became something else. Because a giant ape once really did live in Asia, its name has been attached ever since to every hairy man reported out of a forest anywhere. A scientific label lent to a folklore that has nothing to do with it, by people who wanted the folklore to be true. The animal deserves better than that. It was an orangutan's colossal cousin, living quietly in limestone forests for 2 million years, doing nothing more sinister than eating fruit, undone by a change in the weather. Nothing invented about it is stranger than that.